Okay, let's get on to our last paper, and 26th February evening, JEE Mains 2021. First one is match the column. You have a diazonium salt, and then okay, you have a Cu plus as a catalyst, and then Cu as a catalyst. I think this is Sandmeyer and this is Caterman, and then you have this thing Na dry ether, Wood's reaction with alkyl halides, and Fittig reaction with the aryl halides. You see, this is C6H5 here. So C6H5C. This is also like memorizing the names of reaction. Okay, that's required in organic chemistry sometimes. Not a very nice question though. So let's go for A. So I would like to go with option 4, right? No, sorry. 2. So C, you have 4. Yeah. Now let's move on to the next one. Again, I match the column, and this is what I expected because I see a JEE Mains paper. I saw the last year JEE Mains paper, and I saw a lot of questions from biomolecules and a lot of questions based on test. So this is once again, this is identifying the monomer units. So sucrose, it's very obvious, alpha and beta fructose, and both the anomeric carbons are linked in sucrose, and so many other very interesting properties of this molecule sucrose. Lactose, if you see lactose, you know galactose should be there. So beta galactose and beta glucose, but this can anomerize. This lactose can exist in two forms because one of the chain can open up, so this could even be alpha or beta, but in most of the textbooks it's only beta, so that's fine. Maltose 2 alpha glucose units, so you need to understand this starch goes down to maltose, and then maltose you get alpha glucose units. But even in maltose, out of the two rings which are connected, one of the ring you have an alpha glycosidic linkage, and one of the ring it has this anomeric carbon not connected in a glycosidic linkage. It can open up and uh, recyclize, so that way you can have alpha and beta glucose also, but it's mostly considered alpha, but maltose also has two anomers, alpha and beta. But anyways, so very simple, and that way we go for A2, A2B, what is B, B3, A2B3, this one, fourth C1. Yeah, now let's move on to next one. Which of the following will give positive test with ceric ammonium nitrate and CH3? Okay, so this is a test for alcohol. This is an oxidizing agent, so this I don't remember exactly the color. It has some color, ceric ammonium nitrate, and when it reacts with alcohol, it forms a complex first, and the color changes, and and after that when oxidation happens completely and alcohol is oxidized to aldehyde, and then after that the complex gets colorless. But I'll be making a very a video on this test very soon, but this is a test for alcohol, and this is a test for, as I see the options I can understand, okay, yeah, this is carbylamine test. Yes, this was a question this evening one of my student was talking about. Yeah, so this is the carbylamine test, and this is for amines, 1 degree amines to be more exact. 1 degree amines. So wow, amine and phenol, no, that's wrong, respectively. We should have amine here, and we have amine here, and phenol and alcohol. Oh my god. So as far as I Remember, the steric ammonium nitrate test can be given by both phenol and alcohols also. And phenol, they don't completely oxidize, because you see in phenol you have OH group here and there's no hydrogen here, and you can't oxidize it to anything like this, because you'll get 5 bonds of carbon here. So the oxidation step will not happen, but the color change can happen because of complex formation. So that way both can give, but I would like to go with alcohol. Then that's the only choice remaining, because it will follow both these steps. So there will be oxidation also and color formation also. So we'll like to go with this. I don't know how NTA will solve this situation. They'll go with alcohol, I think. Yeah, let's move on to the next one. Once again, so this is turning out to be a very nice paper according to my predictions, because I have always asked my students to study biomolecules and tests. You know, these two sections, they have been emphasized in previous JEE or J mains examination also, and here in this exam it's all about them from the starting. One question on name reaction, then the other on biomolecules connections, and then test. And now we have again these two tests, Selly Van Hoff test and xanthoprotic test. So I have videos on my channel explaining both of these tests. The xanthoprotic test I have explained in terms of there something happened in World War I, and some women working in a chemical factory for making explosives, their skin and hair turned yellow, and they were called canary girls. So you can find a video on canary girls on my channel, and in that I have explained xanthoprotic test. Xantho means yellow basically, and this is a test associated with your skin pigment melanin, and melanin is in skin, which is a pigment responsible for color of your skin, and this thing got transformed in those girls, and they turned yellow. And melanin is made from tyrosine, and tyrosine is an amino acid. So we see the link here, xanthoprotic test. And Selly-Van Hoff test is very interesting. It's used it's almost like one of those tests in which we have aldoses and ketoses, and to be very frank, we have pentoses and hexoses. What do I mean by that? You can understand it very nicely in the video I'm talking about. I'll post a link in the description. Pentose and hexoses. If you have pentoses and hexoses, then you dehydrate them to get furfural or furfural derivative, or 5-hydroxy methyl furfural. And then you use is something where electrophilic aromatic substitution can occur. And in Selly-Van Hoff test, that thing is resorcinol, as far as I remember. Yes, I think resorcinol. And then what happens in this test, that the ketoses dehydrate faster, and they react faster. So this test is for ketosis. This test is to distinguish between ketoses and aldoses. So this way we think we can see very easily the answer should be ketoses and proteins, right? I don't know if xanthoprotic test is for all proteins or not, because it's a nitration process, but here I would like to go with ketosis and proteins. Now let's move on to the next one. Okay, now what is this? Aldehyde and NaOH, ETOH, aldol condensation, I feel like. Yes, let's see. Okay, this is the question which my student was talking about this evening. And he explained me the answer, so I know what's going to happen. He said And so of course we will have a carbon ion somewhere here, and both sides are same, so we can have carbon ion anywhere, and we will have to attack this on the other carbonyl carbon and make the product. And CH2 CH COH H CH2 CH2, and we have CHO. So this is the thing, and 1 2 3 4 5 6 7, yes, and he was right. He said to me like we have to be careful that there will be 7-membered ring, and yes, this is a 7-membered ring here. And so what we get is 1 2 CHO, 1 2 3 and OH. And then the next step, we can remove water from here, because we can get 2 double bonds conjugated. This is the answer, you can see very easily. Yes, so that is that. And then let's now move on to the next one, where we have this thing is an ketone, and then we use ZnHCl. This is a Clementian reduction, so what you will get is basically this double bond O will be replaced by 2 hydrogens like this, and you will get this thing, and Cr2O3, okay, again a catalyst, and 773 Kelvin, 10 to 20 atm. This again feels like aromatization. So this year I have seen maybe this is 3rd or 4th question based on aromatization, and you have to think how to make a ring here, and hydrogens will be lost, of course, but from which side can you make the ring? And how many carbons here? 1 2 3 4 5 6 7 8, 6 7 8 here, 7 8 here. Yeah, can we make this thing? You see, if it gets connected from this thing gets closed from here, so then we can get a aromatic ring, and like this. And how about 1 2 3 4 5 from here? It's 5 carbon connection, so you can't close it like from this side, because then you'll get a pentane 5-membered ring. You can close it from this side, so can't see how this thing can get formed. So I think I'll have to go with the second option. Let me say once again, how about if this gets close from 1 2 3 4 5, then this is 5, 6 is here, 1 2 3 4 5. Yeah, this is the only way. Yeah, I would like to go with the second option. Now let's move on to the next one. So I am in a complete advantage today, because I talked with one of my students who gave this paper, and he told me about this question also. And in this question, this is SOCl2, and this is very particularly interesting, because this is like the OH group gets replaced by Cl, but in terms of whether the configuration of the chiral carbon is retained or it gets inverted, there we use SOCl2, and there is a discussion about these things in some textbooks say something, some textbooks say something else, but this is SNI kind of a mechanism, internal exchange kind of a mechanism, which is very interesting. Maybe I'll post a video about it very soon. But here we have nothing, there's nothing to concerned with that situation, because they are not asking about the stereochemistry, they're just asking which of the OH will get replaced. So we know that this OH here, in the phenolic OH group, it has a double bond character, right? Because of the resonance here there is a double bond character. So we will have to replace this OH and the other one here, this one, right? So chlorine, they replace this one, this is not right. They replace this one, this is not right. And this is tough, because somebody can go on thinking about this thing, that which of the OH will be replaced first, and whether both of them will be replaced or not, because they haven't mentioned equivalence here. But anyways, I would like to go with 3, because it feels like both of them will get eventually released. And which one first? That could be an interesting question to explore via mechanism. Not gonna go into that. Now let's move on to the next one. What will be the correct basic strength for the following amines? Phenylmethenamine. Phenylmethenamine. Okay, this is the first one. Notice this lone pair is not involved with benzene rings aromaticity, so this is free, and this is a very good base, I feel like, because others I see are aniline. So the second one is NN-dimethyl-aniline. NN-dimethyl-aniline is something like this, and then you have N-methyl-aniline. N-methyl-aniline is like this. This is the third one. This is the second one, and the fourth one is benzenamine, which is another name for aniline. Okay, so the best base is of course the first one, because in all of them these lone pairs are involved in conjugation with the ring, so less available, but here this one is very easily available, and the best one is first. So correct basic strength KB orders. First, it could be the right one, this is not the right one. It could be the right one, this is not the right one. And the least basic will be, now this is very interesting. I remember I was making some slides to on this section, like which one is more basic, and oh my god, I wasn't expecting that this could be asked in any examination, because this is so close. So what we learn is 1 degree amines, 2 degree amines are most basic, and then 1 and 3 could be like here or there. You can have 1 degree amine, then 3 degree amine, then 2 degree amine, and you also can also have 3 degree amine, then 1 degree, then 2 degree, but we say that 2 degree amine is most basic. But this is the case for alkyl amines, not aryl amines. This is the case with alkyl groups, and in this case also, if the alkyl group is not so big, then we would like to give importance to the 1 degree, then we would like to go with here. If the alkyl group is, let's say, a big alkyl group like ethyl group, then the plus I effect becomes important, and 3 degree becomes more basic than 1 degree if there is a confusion. And if the alkyl group is smaller, then this one is preferred. But in case of aryl amines, like here, aniline and N substituted and NN disubstituted aniline, it turns out to be that the 3 degree one is most basic. So here the fourth, this is least basic, this is most basic, and among these two, anybody would who have known about the alkyl amines, they would like to go with the 2 degree, but here the 3 degree will be more basic than the 2 degree. And I wasn't expecting this to happen in any examination, because I myself didn't tell my students about this thing, because already they were so startled to see so many different kind of trends happening there. It's basically the exam, the people who are setting up these questions, they want us to memorize the table maybe, but this is so rude. This is not good. And yeah, so here now we will have 1 phenylamine most, and then 3 and 2, right? This is 3 and this is 2, and this is more basic. N dimethyl 2 is more basic than 3, so I would like to go with the first option here. N dimethyl aniline is more basic than N methyl aniline. Okay, now let's come on to this is the last one. Okay, very good. So we have HCHO and NaOH. Okay, HCHO and NaOH, and we have an aldehyde also here. So we see Cannizzaro reaction. And in Cannizzaro reaction, with HCHO, so the formaldehyde will get oxidized without any exception, and this is the formaldehyde gets very easily oxidized. I don't think I have a very good explanation for that, but yeah, this will get oxidized and you will get HCOONA, and here you will get the alcohol group. So you will have CH2OH and OCH3. And then what do we have now? So we have C2H5Br and NaHDMF. Wow, hydride, sodium hydride. If you have sodium hydride, then it will abstract this H plus from here, and this alkyl halide, this is Williamson synthesis. This is Williamson synthesis. So you will get this alkoxide ion first. Ether will not take part. This alkoxide ion first. So H minus will abstract the H plus, this H plus, and then you have C2H5, CH3, CH2Br. So this will attack here, and this is a primary alkyl halide. So this can happen, Williamson synthesis, and we have CH2O, CH2CH3, and we have OCH3. And this is now turning out to be a question about cleavage of ethers. Yes, HI and heat. Okay guys, HI and heat, both, whether we have to break both of these ethers or only one. So that is for us to decide. My god, because here they have broken only one, and in some of them, some of the options, they have broken both of them, right? Let's see now. Let's see what should we do. So the H plus will protonate these two ethers, oxygens. So you will get CH2O, and H will attack here, and CH2 CH3, and here you will get CH3, and then the I minus can attack now, and I minus will attack at which side? At here you can see, if this bond breaks up, you can get a carbocation here, very nice carbocation, benzyl carbocation here. So this will happen very easily, and this cleavage will be SN1, and you will get a benzyl carbocation, and then the I minus can join here. But at this side, from this side you can't break this bond, because you will get a phenyl carbocation. From this side you can't break the bond, because you will get a methyl carbocation. So eventually you will have to attack the I minus according to steric hindrance, less steric hindrance group. Here C will attack, and this will be SN2 cleavage. If you're not aware of this cleavage of ethers, do go through them, because there are two ways in which an ether can cleave, SN1 or SN2, and both of them, this thing has been asked like many times in JEE examinations, advanced or mains. So what you will get here, if you break the ether correctly, you will get a CH2I here, because here the carbocation will be formed very easily, and SN1 cleavage, and here you will get this bond breaking up in SN2 mechanism, and you will get a phenol here. So if this is an option, I would like to go with it. CH2I and OH. CH2I above and OH. That's the first one. I would like to go with it. I would like to go with it. Yes. This is also this. You can also go with this, but they haven't mentioned about how many HI they are using. So in that case, I like to go with the complete reactions anyways. So thanks for watching. Have a nice day. This was the most interesting paper I solved this year from JEE Mains. Have a nice day.